Please make a selection. The deeper we go in a fluid, the higher the pressure becomes. The density of a fluid also affects its pressure. Density is a measure of weight per unit of volume. Some common measurements of density include pounds per gallon, or ppg, and pounds per cubic foot. Water, for example, has a density of around 8.34 ppg and a density of 62.35 pounds per cubic foot. The higher the density of the fluid, the greater the pressure at a given depth. Notice the difference in pressure. The pressure that a fluid exerts against the walls of its container is measured in pounds per square inch, or psi. Because we typically measure fluid density in pounds per gallon, or ppg, and because we measure pressure in psi, we need a conversion factor to equate fluid density to psi. This conversion factor is generally rounded off to 0.052. Remember this number because it is used frequently. To find out how much pressure a fluid of a certain density exerts at a given depth, we calculate what is called the pressure gradient of the fluid. The pressure gradient is a measure of the rate of change in fluid pressure per foot of vertical depth, and is expressed in psi per foot. The pressure gradient of water, for example, is 0.433 psi per foot. To find a fluid's pressure gradient in psi per foot, we multiply the fluid's density in pounds per gallon, or ppg, by the conversion factor of 0.052. Let's calculate the pressure gradient for water. Pure water weighs 8.34 pounds per gallon. Out in the field, you'll be using a calculator to get the correct answer. To demonstrate your ability to perform calculations in this course, use your own calculator. First, we'll start by typing the numbers into the boxes. The fluid density box is highlighted. Type 8.34 into the box using the keyboard and hit the Enter key. That's correct. Now type 0.052 into the conversion factor box and hit the Enter key. That's correct. Now use your calculator to work the problem. For pressure gradients, your answer should be carried to 3 decimal places. Type your answer into the pressure gradient box and hit the Enter key. That's right. For every foot of water depth, the pressure increases by 0.433 psi. Now, try your hand at calculating the pressure gradient of a fluid in psi per foot. Let's say
the pump room reported the pressure as 800 psi. The standpipe gauge fluctuated. The correct answer is highlighted in white. Click the Continue button to proceed. The circular. Copy and use this formula to calculate your answer. Click Close to proceed. That's not right. We have solved the problem for you. Take a few minutes to study the solution so that you can perform the calculation yourself during the exam. Click Close to proceed. In order to perform a leak-off test, which of the following valves should be closed if the other valves are open if the cement pump is to be used? You're correct.